Okay. Okay, now, similar to the area function, A E1 star into star minus into star E1 star. We can show that the volume function can be written as a tensor in R3 star tensor R3 star tensor R3 star and this is how we can write it. Okay, write it. So B is just this time we have E1, E2, E3, E1 star, tensor E2 star, tensor E3 star, and then we do what? Like this one, whenever you interchange two of them, you will pick up a minus sign. There are here two terms because we have two factorial many terms, right? What we know is that you cannot have the same indices repeated, right? You cannot have E1, E1 because those gives us 0. So if you may have E1, E2, E3, or E1, E3, E2, or E2, E3, E1, and so on. We have 6 many permutations. Therefore, we have 6 terms like this one, right? We have 6 terms. I need a tensor which will give me this coefficient, another tensor which will give me this coefficient, and so on. For this one, what will be the tensor? It will be this one. This will give me A1, this will give me B2, this will give me C2. Okay? So, if I, for example, interchange this two, I will pick up a minus sign and then E3 star. And then what I can do, I may interchange this two. So another minus sign, so it will be plus E2 star, E3 star, E1 star. Or I can do the following, I can interchange this two. So E1 star, E3 star, E2 star. Or I can interchange this two. Another minus sign, so it will be plus E3 star, E1 star, E2 star. Bir tane daha lazım. Hangisi kaldı? E3, E2, E1. So I can just interchange these two and E3 star, E2 star, and E1 star. Tamam mı? Now let's see why these are the same. When I plug here A1, B1, C1, A2, B2, C2, A3, B3, C3. This is what I get, right? Now let's see what this gadget gives us. So this guy applied to this three vectors. This one will eat the first vector. This one will eat this vector, and this one will eat this vector. So when this guy eats this vector, it gives me what? First, this is just A1 times E1, B1 times E2, C1 times E3. So E1 star eats this guy, it gives me 0 here, but here it will give me 1, and coefficient is A1. So when this guy eats this one, it will give me A1. This guy eats this one, and it will give me B2. And this guy will eat this guy, and it will give me C3. What about this one? A2 bunu inceleyemeyecek. When E2 eats this guy, it will give me B1. And then this will eat this one, and it will give me A2. E3 will eat this guy, and it will give me C3. Plus E2 will eat this guy, it will give me B1. E3 will eat this guy, and it will give me C2. And E1 will eat this guy, and it will give me H3. Minus E1 will eat this guy, A1. C2, B3, and this guy, C1, A2, B3. Okay, C1, B2, and H3. Aynısı mı? A1, B2, C3, A1, B2, C3, minus A1, B2, C2, minus A1, A1, B2, B3, C2. Evet, bu kelime değil mi? B1, A2, A3, B1, A2, A3, pardon, C3 var. Evet, öyle var. Eksi değil mi? B1, C2, A3. O da var. So, you see that this volume is just this expression. You know, it gets complicated as you see quickly, right? It looks complicated because we didn't write it using enough mathematics. We have to put more math into that.
You mean just the term and all time?
Yeah, it will be determined, yes. Efendim? Evet, öyle olacak. Şimdi okay, now we will have a notation again, notation. Remember, for two vectors, V and W. So let me view V and W are vectors in the vector space. U and V is, let's say, U tensor V. No, U wedge V neydi? This is U tensor V minus V tensor U. For this object, we will have also a notation. So U V W V tensor no, U tensor V tensor W. This will be just this object. So what it means, U tensor V tensor W, and then whenever you make it transposition, you pick up a minus sign. So V tensor U tensor W. Şu ikisini yerini değiştirelim. Şu ikisini yerini değiştirelim. Sonra ne yapalım? Bir de şu ikisini yerini değiştirelim. Yok. Şu ikisini yerini değiştirelim. Artı W tensor U tensor V. Bir de bu ikisini yerini değiştirelim. W tensor U tensor V. Bu sefer bunu eksilteceğiz. Okay. So this is just a shorthand writing for these tensors, okay? This is a tensor in V tensor V, and this is a tensor in, so this is V tensor V tensor V. Okay? Just the definition. And we will read this as U wedge product with V, and this is U wedge product with V wedge product with W. So this is triple wedge product, this is double wedge product.
Buradakiyle oradakiyle aynı şeyleri bir space'leri harcayın.
Evet, evet. O kadar harfimiz yok. Yani o yüzden hesap kullanacağız. Biri fonksiyon, biri uzay. Tamam mı? Yani bu wedge product dediğimiz şey nedir? Bunu yazmak istemiyorum her seferinde. Yani U wedge, V wedge, W diye bunu yazmak istemediğim için sadece bunu yazacağım. So if you just compare this two, hence so we can write our area and volume functions in terms of wedge products then. Note that in this case we get, so area is just, it was this, right? Area was E1 wedge, E1 style, sorry. Okay, let me write here. What is this? This is just, you know, E1 star wedge E2 star. And what about this one? Right, this is just this thing. E1 wedge, E2 star, wedge, E3 star. So we have this E1, E2, and volume is just okay. And you see why this notation is good, right? I mean, otherwise you have to write this one.
Aslında bu için bize hacim birimi belirlememize mi yani? Yani hacim birimi belirlemeden fazla tutanlar değil mi?
So this is just a notation for this campus.
Yani burada da mı hacim birimi belirlemişti? İvan belirlemişti.
Yok, yani bunu şey için, so our area function and volume function can be written as these functions, right? This is a function which eats 2 vectors. This will eat 3 vectors. And how this will eat 2 vectors? Well, this is a tensor, right? And you know how this tensor eats vectors when you have a pair of we have when we have UV, so E1 star with E2 star UV. How this will eat this guy? Well, we have to remember what is this. This is a tensor. This is E1 tensor E2 minus E2 tensor E1. So this is just E1 star U E2 star V minus E2 star U E1 star V, right? And similarly, this one. But here you have 6 terms. Okay. So area, volume are motivations for this, algebraic concepts. But this algebraic concepts exist even if we don't, if we are not interested in area or volume. So this algebraic object exists, but they come from a natural, need, like computing area and volume. Yani veci, tensörü tamamen cebirsel olarak tarif edebiliriz ama aslında arka planda hani geometrik bir şey var, amaç var. Okay. Now we will define hence wedge product formally. So I have defined that I have defined already wedge product of 2 vectors or 3 vectors, but what about in general? Şurada belki şey de söylemekte fayda var. Ya da neyse, tamam. Şöyle. Definition of formal definition of external product. Exterior or wedge product. We may call it exterior product or wedge product. So it has 2 names. Okay. Okay, definition is the following. Given a vector space, we define a new product. Product space V dash W called the exterior product. Or another name, anti-symmetric product. Why anti-symmetric? Because when you replace two entries, U and V, you pick up a minus sign. So it's not symmetric. V wedge W, U wedge V is not V wedge W, but it is minus, right? So when you switch to components, you pick up a minus sign. That is called anti-symmetric. It is not symmetric, but anti-symmetric. When you switch to components, you pick up a minus sign. That's why it's called anti-symmetric product also. Anti-symmetric anti-symmetric tensor product. Or alternating product. Or wedge product. So it has at least 4 names, okay? Of 2 copies of the space V cancels V dash V is the subspace of V cancel V. So it's a subspace of this because you know wedge product, and this is an element in the tensor product. This is the product in the tensor product. So wedge products lives in tensor products. That's why this is the subspace of V spanned by or consisting of all vectors of the form from V1 tensor V2 minus V2 tensor V1 and linear sums. Yani bu tip nesnelerin linear combination. So a typical element of V dash V as the form nasıl bir şey olacak? Summation, let's say CK V1 VK tensor not tensor which UK K from let's say from 1 to I don't know N. Something like this. Yani ya da şöyle. UK instead of this I can write the following UK tensor UK minus UK cancer. Tamam mı? Yani bu tensörlerin içinde bir alt uzay. So this is a subspace in the tensor space. Okay, consisting of such tensors. They are alternating tensors. Okay. Okay. Wait, back. Satisfied. Properties. Nedir onlar? So UHV is the same as V, nothing is the same, minus VHU, right? Second, lambda U VHV is lambda UHV. Third, U plus V VHX UHX plus VHX. Okay. This is called anti-symmetry, and these are linearities, right? You can take this constant and plug either in front of the first vector or the second vector, because this is basically this one. And you can, if you have a sum here, this wedge product distributes over addition. Bunları nasıl gösterebiliriz? Well, we can just use the definition. I mean, okay. I don't have, I guess, time. Let me stop. So next time I'll start from this, and then we will see that I can just actually use these axioms to build everything. Okay. I don't need to consider areas or volumes. Just using these axioms, I can build this algebraic object.
Çünkü product sadece V 3 tane V olması gerekiyor.
Arkadaşlar 5 dakikanızı alabilir miyim? 5 dakikanızı müsaade etsem sizden. Biliyorsunuz temsilcilik seçimleri oluyor.